Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers volume and surface areas. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. In question 27, the examiner has rather kindly reminded us of the volume of a pyramid formula. We are told that the volume of this particular pyramid is 336 cubic meters, and we're being asked to find the angle between VB and the base. So being asked to find that angle there. Right, now in order to find that angle, I think what we need to do is use some trigonometry in this triangle XVB. Now in order to use trigonometry in that triangle to find that angle, we're going to need two sides of the triangle. Now we can use the volume formula to work out the height of the triangle, and we're going to have to use some Pythagoras theorem along the base somehow to find the other length XB. And once we've got those, we should easily be able to find the angle. Okay, so let's do that then. Let's start off with the volume of the pyramid. So volume equals a third of the base times the height. So in this case, the volume was 336 equals a third times the area of the base, which is a rectangle, 14 times 8 times the height, which we don't know, let's call it h. So then h is going to be 336 times 3 divided by 14 and 8. So typing that into my calculator, 336 times 3 divided by 14 divided by 8 is 9. So my triangle, sorry, my pyramid has a height of 9. Okay, so we're almost there. Next we need to find the length XB. So kind of this length here we're looking for. Now we can do that by forming a right angle triangle here. So by cutting AB in half, let's just draw that line a little bit more in line with the diagram. So cutting AB in half, so this line is 7, this would be a right angle, and this side here would be 4, half of BC. So let's just quickly sketch that here. So this was X, this was, let's call that point M, and B, we know that's a right angle, we know that's 4, we know that's 7. So what we want is XB. So using Pythagoras theorem, XB squared equals 4 squared plus 7 squared, making XB the square root of 16 plus 49, which is root 65. Now that doesn't square root nicely, I'm just going to leave it like that for now. Okay, so now we've got this side here, which is root 65, and we know h is 9, and we've got another right angle triangle here. We can then use triangle XBV to work out the angle. So again, let's just take that triangle out and draw it down here. So this is the tip of the, so it's V, isn't it, at the top? This is the tip of my triangle. So this is X. So this is B down here. So right angle triangle. H is 9. And this side here is root 65. We want to find this angle here. Let's call it theta. So trigonometry in this triangle, if that's the angle I'm looking for, then 9 is the opposite and XB is the adjacent. So I need to use tan. So tan theta equals opposite, which is XV, divided by adjacent, which is XB, which is 9 over root 65. So I need to divide that and then find the inverse tangent of it. So inverse tan, inverse tan 9 divided by square root of 65. I'm making that 48.1 and a bit. So 48.1 to 1 decimal place. 48.1 degrees. Question 17. Here are 2 closed containers. 4 tennis balls just fit in each container. Each tennis ball has a diameter of 64 millimeters. Which container has the smallest surface area? You must show your working. Okay, so we're told that the diameter of each tennis ball is 64. So that means that this dimension of the cuboid is going to be 2 64s, which is 128. This is also going to be 128 because it's 2 tennis balls, and the height is going to be 1 tennis ball, which is 64. For the cylinder, we have got a dimension in this direction of 4 tennis balls, 4 lots of 64, whatever that is. I'll work it out in a second. And if we're working out the surface area, we'll need the radius of this circle, which is going to be half of 64, which is 32. Okay, that should be enough to work out the 2 surface areas then. So let's do the surface area of the cuboid first. So let's just switch pen. Surface area of cuboid. Now it's the 6 faces, isn't it, added together. There is a brief formula for it. You can say length width plus width height plus height length. So basically you just switch the 2 of the 3 dimensions like that, which is 2 lots of 128 squared for the base, and then you've got the side panel, which is 128 times 64, and another one of those. So I make that 128 squared plus 128 times 64 plus another 128 times 64, and then doubled. It's got a surface area of 65,536. 65,536. And that's going to be in millimeters squared. Okay, so that's the cuboid. Next we need to calculate the cylinder. So surface area of the cylinder. Now the cylinder is made up of 2 circular faces and that curved surface area. So we're going to get 2 pi r squared, which is our 2 circles, plus we're going to get the curved area of a cylinder, which is the circumference of the end, which is going to be pi times the diameter, or 2 pi r, and then multiplied by the length, or the height. Normally use h for cylinders. So subbing in the values, It's going to be 2 times pi times 32 squared plus 2 times pi times 32. We said that was 4 times 64. Just going to write it in like that for now. Work it out with the calculator. So tapping that in, 2 pi times 32 squared plus 2 pi times 32 times 4 times 64. I make that 57,906 to the nearest unit. That's in millimeters squared. So I'm just going to write underneath my conclusion, which is the cylinder has the smallest surface area. Okay, question 19, we're reminded of the formula for the surface area of a cone, which is pi RL, and we are given a diagram which shows a hollow cone made from thick glass. So the radius of the outer cone is 10 centimeters, the slant height of the outer cone is 25. So let's add those into the diagram. So the radius of the outer cone is 10. So the distance from here to here then is 10. The slant height of the outer cone is 25. So from there up to there is 25. The radius of the inner cone is 5 centimeters. So from there to there is 5 of the equal cone, and the slant height of the inner cone is 12.5. So 12.5. Okay, so work out the total surface area of the glass. So it's going to be made up of 3 separate surfaces. It's going to be the curved surface area of the large cone. It's going to be the curved surface area of the smaller cone, and it's going to be that disc, which is the difference between the 2 circles. Okay, so we've got a fair bit of work to do here. So let's work out each part and then work out what we need to do with them. So the outer curved area is going to be area equals pi RL, which is pi times the radius, in this case is going to be 10, times the height, which is 25, so that's 250 pi. The inner curved area, let's call it A1 and A2. A2 is going to be pi RL again, so we said that the inner radius was 5 and the inner slant height was 12.5, so that's pi times 5 times 12.5, which is 12.5 times 5, 60. That's not right. 12.5 times 5, 62.5, so that's 62.5 lots of pi. So large circle, A3 is going to be pi r squared with a radius of 10, so that's going to be pi times 10 squared, which is 100 pi. And then the small circle, which we can call A4, is going to be pi r squared again, where the radius is 5. So that's going to give me 25 pi. Okay, so then the total surface area is going to be then my 250 pi plus my 62.5 pi plus my 100 pi, subtract my 25 pi, because that's the bit of a small circle that doesn't actually exist. So what's that? 250 plus 62.5 plus 100 minus 25. So that's 387.5 lots of pi. Which multiplied by pi gives me 1,217 and change, which I'm just going to round off to 1,217. Question 20. Prove that 3 lots of x plus 1 times x plus 7 minus 2x plus 5. In question 22, we're helpfully reminded of the volume of a sphere formula, which is 4/3 pi r cubed. And we've been given a cylinder which has radius of x. Let's just write this on as we go. So it's got a radius of x and a height of h. Okay, and a hemisphere that has a radius of 3x over 2. 3x over 2. And we know that the ratio of x to h is 4:9. Okay, so that means we can replace h in this diagram with x, can't we? So if x to h is 4:9, that means if I take x and I divide it by 4 and I times it by 9, I should get h, which means I can rewrite h here as 9x over 4. Okay, and then that means I'll have everything in for my cylinder in terms of x and everything in my hemisphere in terms of x, so I should be able to equate their two volumes and solve for x. Okay, so let's just do that then. So the volume of the cylinder is going to be equal to, right, it's a prism, isn't it? So it's the area of the cross section, pi r squared times the distance between them, h, which in this case is pi, we know the radius is x, so radius squared times h, which we now know in terms of x as well, that's 9x over 4. So that gives us x squared times x, which is x cubed. So I'm going to have 9x cubed over 4 lots of pi. I'm going to leave it in terms of pi for now for simplicity. And then the hemisphere, what's the volume of that then? So it's going to be half our circle volume. So the volume of a sphere is 4/3 pi r cubed. So half of that is going to be 2/3 pi r cubed, isn't it? So the volume of my hemisphere is half of 4/3 pi r cubed, which is 2/3 of pi times r cubed, and we said r was 3x over 2. So 3x over 2 all cubed. So that gives me 2/3. Let's just cube out this bracket then. So 3 cubed is 27. X cubed is x cubed over 2 cubed, which is 8. So multiplying everything out there. And then combining our fractions. 3 goes into 27 9 times. And 2 goes into 8 4 times. So that simplifies things a little bit. So that leaves me with 9x cubed over 4 pi, which is the same result I got for the cylinder. So I seem to have proved then that they are of equal volume. So cylinder and hemisphere are equal. In question 28, we're told that the volume of a cone is 1/3 pi r squared h, where r is the radius and h is the perpendicular height. A cone has a horizontal base of radius 5, a height of 15, and the cone contains water to a depth of 9 centimeters. work out the volume of the water. Okay, so basically we're trying to find the volume of that frustum part at the bottom. Now a frustum is made up of a cone with a cone taken off the top. So if we can work out the volume of the entire cone, this one, and then we can take away the volume of this smaller cone, we'll be left with the volume of the water. That's the plan. Okay, so a volume of the, should we do it in 3 parts? So the volume of the large cone is going to be 1/3 of pi r squared h. So 1/3 of pi r squared h, which is equal to, in this case, the big cone has got a radius of 5 and a height of 15. So that's going to be 1/3 of pi times 5 squared times 15. Okay, so I can divide the 3 into the 15. That is move 5, and 5 squared is 25 times 5 is 125. So that means that the volume of the large cone then is going to be 125 lots of pi. Okay, so now let's do the smaller cone. Volume of small cone. Now the small cone is this green one up here. Now what we need to do is work out the radius and the height of this cone. Now the height's easy enough. It's the difference between the 9 centimeters and the 15 centimeters. In other words, it's got a height of 6. Now because the large cone and the smaller cone are similar, they have the same angles, etc., all their sides are going to be in the same ratio. So then the radius of the smaller cone is going to be 6/15 of the radius of the larger cone. Now 6 being the height of the small cone and 15 being the height of the larger cone. That's where the 6/15 comes from, and 5 is the radius of the larger cone. So our smaller cone has a radius of 6/15 of 5. So dividing that out, divide that 5 into that 15 gives me 3 and 1. 6 divided by 3 is 2. 2 times 1 is 1. So the radius of the small cone then is going to be 2. So volume of the smaller cone is 1/3 times pi times r squared times h, which is 1/3. We said the radius was 2 squared, and the height is 6. Again, let's just simplify that out. 3 goes into 6 twice. So, oh, and don't forget the pi. Almost forgot the pi. Let's squeeze that in there. So 1/3 cancels with 6, leaving 2. 2 times 2 squared. 2 squared is 4 times 2 is 8. So basically the small cone has got a volume of 8 pi. Okay, so then the volume of the water is going to be volume of the large cone, take away the volume of the small cone, which is going to be 125 pi, take away 8 pi, which leaves us with 117 lots of pi. Question 18. Here is a tunnel for a toy train. So it's a kind of prism, isn't it? So you've got a uniform cross section running all the way through for a certain length. Okay, whatever the length here, and then this is the cross section, so it's a prism. Okay, now the diagram below shows the cross section of the tunnel. AD is semicircular arc of radius 10, and BC is a semicircular arc of radius 7, and the length of the tunnel is 30. Work out the total area of all 6 faces of the tunnel. Give your answer in terms of pi. Oh, So they want the surface area here, not the volume. That's going to be fun. So it says there are 6 faces. It tells us in the question. Where are those 6 faces? Okay, well, we're going to have this front face here, aren't we? Which is going to match up with a similar back face at the end there. It's going to be exactly the same. Then where are the other faces? Well, we're going to have this kind of curved side here that goes all the way around the top. But then we're also going to have another one inside, if you see what I mean. Now when you straighten that out, that's actually going to be a rectangle, isn't it, that wraps all the way around there. And then we've got kind of its feet. So these feet part here and another one there, look, so they're going to match up. So those 2 are going to be the same. So the front face is going to be the same as the back face. Those 2 feet are going to be the same. And then we're going to have 2 different size rectangles that are wrapped around the inner and outer part. They look curved there, but when we straighten them out, they're going to be rectangles, aren't they? Okay, does that make sense? So this is quite a long question. Well, we're going to have to get stuck in. Let's get busy with it then. So let's start with this bit here then. Okay, this kind of C-shaped part. So that is going to be half of a circle with a smaller circle cut out of the middle, isn't it? So it's going to be half of like the big circle, which I'm going to get with pi r1 squared, take away the smaller circle in the middle, pi r2 squared, okay, which is going to be half of, well, the bigger radius is this one here, isn't it, 10, and the smaller radius is this one, 7. So it's going to be half of, I'm just going to factorize pi out as well, out of that bracket. So I'm going to get r1 squared minus r2 squared. So r1 is 10 squared, r2 is 7. So it's going to be pi times 10 squared minus pi times 7 squared. So I'm factorizing the pi out. So I've got pi over 2 times 10 squared is 100 minus 7 squared, which is 49. So that's 100 subtract 49, which is 51, isn't it? So it's going to be 51 pi over 2. I'm going to leave it in terms of pi for now. Well, I'm going to have to because I haven't got a calculator. So it's 51 pi over 2. Now the back face is also going to be 51 pi over 2 because it's identical to the front part. Okay, so doing well. We've got 2 done already. Right, now what about the green bit then, like the outer rectangle? Now, let's say that is a rectangle, isn't it? And this part of the rectangle is this side here. Okay, so it goes all the way around. It's the half the circumference of that bigger circle, isn't it? So that distance is half the circumference of the bigger circle. So the bigger circle has got a radius of 10, which is a diameter of 20, so a circumference of 20 pi. So it's going to be pi times the diameter, and then we're going to halve it, aren't we? Pi times diameter over 2, which is 20 pi over 2, which is 10 pi. Yeah, and then the length of the tunnel was 30 centimeters. So from here to here is 30, and from there to there is 10 pi. So then the area of that bit then is going to be 30 times 10 pi, which is going to be 300 pi. Okay, so the green part is 300 pi. We're getting there slowly. So what about the blue part? Okay, so that's the other curved surface, and it's made up of a rectangle again. This time the rectangle distance around here, this bit here, is going to be half the circumference of the smaller circle. So if you remember, the smaller circle had radius 7, so it has diameter 14. So again, it's going to be half pi d, half the diameter, half the circumference of the smaller circle, where here the diameter is 14. So it'd be 14 pi over 2, which is 7 pi. The length is still the same, it's still 30. So then the area of that rectangle is going to be 30 times 7 pi, which is 210 pi. Okay, so doing well. We've got 4 out of the 6 sides done now. Finally, we've got 2 matching rectangles which make up the feet of this shape. It's these rectangles here, look. Okay, now that is going to be another rectangle shape. This time the rectangle is going to have a length of 30 again. Would have been easier just to work. No, it wouldn't have done. Well, I'm doing fine. So okay, so it's got to have a length of 30, and what is the width? The width is going to be the difference between these two radiuses, isn't it? From there to there was 7, and from there to there is 10. Oh, it even tells us it's 3. Okay, so it's just going to be 3. So it's going to be 3 times 30. 3 times 30 is 90. No pi's for this one, it's just a rectangle. Okay, and then obviously the other one there is also 30. That one in there is going to be 30 as well. Okay, so what are my 6 faces then? So then the total surface area, I'm going to add those 6 things together. So I'm going to have 51 pi over 2 twice. So it's going to be my 51 pi over 2 and another 51 pi over 2. That's the kind of that bit. Then I've got my 2 feet, which are 90 and 90. Plus 90 and 90. And then I've got my big rectangle, which was 10 pi, no it wasn't, it was 300 pi, and my small rectangle, which was 210 pi. So plus 300 pi plus 210 pi. Okay, so 51 pi over 2 plus 51 pi over 2 is just 51 pi, isn't it? So that's 51 pi, and adding that to my 300 and my 210 pi, 300 and 210 is 510, plus 51 is 561. 561 pi plus 90 and 90 is 180. So that is my final answer, 561 pi plus 180. Now that was bags of fun, wasn't it? Question 16. Some concrete has volume 3.8 cubic meters. The density of concrete is 2,400 kilograms per cubic meter. Work out the mass of the concrete. Okay, well there is a handy formula involving density, mass and volume. Do you know what it is? Density is equal to mass over volume. That's one that you might find handy for science as well. So we have here, we've been given the density and we've been given the volume. What we want to know is the mass. So we really want to rearrange this equation so it's in the form of mass. So kind of cross multiplying this volume up here, I can then say that mass is going to be equal to density times volume. Density we said was 3.8. Let's just check the units match. That's in cubic meters and the other one is kilograms per cubic meter. They seem to be matching up. So I can multiply them together and it will give me my answer in kilograms then, won't it? Okay, reaching for a calculator. 3.8 times 2,400 gives me 9,120 kilograms. 9,120 kg. Okay, part B. The 3.8 cubic meters of concrete is made into the shape of a cylinder. The base has a radius of 0.5 meters. Work out the height of the cylinder. Okay, so what do we know? We know the mass of this is 9. So we know the volume, don't we? The volume. Might as well just use the volume. So 3.8 meters cubed. So that's the volume. So that's the volume. We know the radius. So what we want to know is h, the height. Now, luckily, I know a formula for cylinders. A cylinder is just a circular prism, isn't it? Okay, and the area of the volume of a prism is the cross-sectional area, which in this case is a circle, pi r squared, times its height. So using the fact that volume is equal to cross-sectional area, pi r squared, times the height, I've got all the bits that I need here then, isn't it? I'm going to rearrange for h. So taking this bit and moving it down there, look, I can say that h then is equal to the volume divided by pi r squared. Okay, what's that equal to? The volume we said was a 3.8 cubic meters, and we need to divide that by pi times r squared, 0.5 squared. Time to reach for the calculator again. So 3.8 divided by 0.5 squared divided by pi is 4.838, which I'm going to round off to 4.84. 4.84 meters. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.